Docker and CI/CD. Docker and continuous integration, continuous deployment, CI/CD, are a powerful combination that helps streamline the software development and deployment process. Docker's containerization technology enables consistent environments across various stages of the development lifecycle, while CI/CD practices automate the build, test, and deployment processes. Here's how Docker and CI/CD work together. Continuous integration, CI. C involves regularly integrating code changes from multiple developers into a shared repository. Automated testing and validation are performed to catch integration issues early. Docker plays a significant role in creating consistent environments for testing and reducing "it works on my machine" problems. Dockerizing applications. Docker allows you to package applications, along with the dependencies, configurations, and runtime environment, into containers. This ensures that the same environment is used for testing as in production. C pipelines. C tools like Jenkins, GitLab C, CD, Travis C, and Circle CI can create Docker containers, run tests, and build application artifacts. Docker images can be built from Docker files or using existing images as base. Parallel testing. Docker's lightweight containers make it feasible to run parallel tests across different components of your application, improving testing efficiency. Continuous deployment, CD. CD extends C by automating the deployment of successfully tested code changes to various environments, including production. Docker simplifies the deployment process by ensuring consistent environments from development to production. Immutable infrastructure. Docker images are immutable. Instead of updating running containers, you deploy new images with each release. This eliminates configuration drift and ensures that the application behaves consistently across environments. Orchestration. Tools like Kubernetes and Docker Swarm orchestrate the deployment of containers across a cluster of servers, ensuring high availability, scaling, and load balancing. Blue-green deployments. Docker enables blue-green deployments, where a new version of the application is deployed alongside the existing version. Traffic is switched to the new version after it's tested and validated. Rolling updates. With Docker Swarm or Kubernetes, you can perform rolling updates, gradually replacing old containers with new ones. This minimizes downtime and service disruption. Benefits of Docker and CI/CD. Consistency. Docker ensures consistent environments across development, testing, and production, reducing environment-related bugs. Faster testing. Containers provide isolation, allowing you to test different parts of your application in parallel, leading to faster test execution. Isolation. Docker containers isolate applications and the dependencies, preventing conflicts and providing cleaner integration testing. Efficient rollbacks. Immutable containers make it easier to roll back to previous versions by simply redeploying an older image. Version control. Docker images can be versioned and tracked, enabling you to revert to specific states if needed. Scalability. Docker's containerization and orchestration tools allow you to scale your application horizontally. DevOps collaboration. Docker's consistent environments facilitate collaboration between development and operations teams, promoting DevOps practices. Incorporating Docker into your C/CD pipeline enhances consistency, reliability, and agility throughout the software development and deployment lifecycle. Integrating Docker into continuous integration and continuous deployment pipelines. Integrating Docker into continuous integration (CI) and continuous deployment (CD) pipelines involves using Docker containers to build, test, and deploy applications seamlessly. Here's a step-by-step guide to integrating Docker into your C/CD pipeline. Continuous integration (CI) pipeline. Create Docker images. 1. Write Docker files to define how your application should be containerized. 2. Version your Docker files alongside your code. Version control and repository. 1. Use a version control system like Git to manage your codebase and Docker files. 2. Store your Docker files in the same repository as your application code. C configuration. 1. Set up a configuration file for your C tool, e.g., GitLab c.yml for GitLab C/CD, in your repository. 2. Define C jobs that build and test your Docker images. Build and test jobs. 1. Create C jobs that use Docker to build images and run tests. 2. Use Docker Compose or custom scripts to define the test environment. Artifact storage. 1. If needed, store built Docker images in a container registry, e.g., Docker Hub, GitLab Container Registry. Automated testing. 1. Integrate automated testing tools within your Docker containers to validate code changes. Continuous deployment (CD) pipeline. CD configuration. 1. Extend your C configuration to include CD stages. 2. Define CD jobs that push images to a container registry and deploy them. Registry configuration. 1. Configure access to the container registry in your CD tool. 2. Use environment variables or secrets to securely manage credentials. Deployment strategies. 1. Implement deployment strategies such as blue-green deployments or rolling updates. Orchestration. 1. If using orchestration tools like Kubernetes or Docker Swarm, define deployment manifests or configurations. Artifact promotion. 1. Promote successfully tested images from the C registry to a production registry or a staging environment. Automated deployment. 1. Set up triggers that automatically deploy images to staging or production upon successful C tests. Benefits. 1. Consistency. Docker images ensure consistent environments across development, testing, and production stages. 2. Isolation. Containers provide isolation, preventing conflicts between different components during testing and deployment. 3. Efficiency. Containers enable parallel testing of different application components, leading to faster C tests. 4. Version control. Docker images can be versioned and tracked, allowing you to easily roll back to previous states. 5. Immutable infrastructure. Deploying immutable Docker images ensures reproducibility and eliminates configuration drift. 6. DevOps collaboration. Docker's consistency fosters collaboration between development and operations teams. Example C/CD tools. 1. Jenkins. Use Docker plugin to run Jenkins agents in Docker containers. 2. GitLab C/CD. Built-in Docker support for building and deploying Docker images. 3. Travis C. Build and test Docker images using Docker Compose. 4. Circle CI. Run C/CD jobs inside Docker containers. Remember that the exact implementation might vary based on your tools, applications, and deployment requirements. Properly integrating Docker into your C/CD pipeline helps you deliver applications more reliably, quickly, and efficiently. Thanks for watching.